The applicability of any well configuration, complex architectures included, depends on reservoir parameters and economic considerations. Multilateral wells, for example, are appropriate for targeting different geological flow units from a single vertical trunk. This enables us to develop fields with fewer surface locations. Multilaterals can also be drilled to intersect several locations within the same reservoir, thereby increasing a well's drainage volume and improving sweep efficiency. This is particularly beneficial in low to moderate permeability reservoirs, where the higher per-well recovery can more than justify the added drilling costs. The benefits are somewhat diminished in higher permeability reservoirs, where larger drainage radii may cause cross-branch interference among well bores. In most horizontal wells, the friction pressure loss along the lateral section is negligible with respect to the pressure drawdown. But in some, wells in under-pressured reservoirs, for example, or those that are susceptible to pressure drawdown, it is significant. In such cases, it may be necessary to reduce the friction pressure by drilling two opposing laterals. Such configurations are widely used in strong bottom water drive reservoirs and in naturally fractured formations. In reservoirs with pronounced aerial permeability anisotropy, where a horizontal well's productivity depends on its orientation, we can reduce the risk of misorientation by drilling two multilaterals in a cross configuration. Multi-branched wells, drilled from a horizontal trunk, can be designed for various formation characteristics and reservoir geometries. In the case of this river channel, our first instinct might be to drill a single well along its length. But frequently, the permeability along the channel path is several times higher than the transverse permeability. A well drilled along the channel path thus exhibits less than optimal productivity. In this situation, we would be better off to drill a horizontal trunk, even if it is outside the channel but tracing its path, and then drill several short radius horizontal branches normal to this path. The higher productivity that would result may be well worth the additional drilling costs incurred. We can also drill vertical branches from a horizontal trunk. In this case, the branches have been hydraulically fractured in sequence. This configuration offers similar results to a multiple transverse fracture treatment